Welcome to DragonCon Goes Virtual. This is the science track, and we're here for the science of cosplay. We have collected a lot of questions from various locations on the interwebs, and we're going to do our best to answer the most of them and have a pretty engaging conversation here about the science of cosplay. So why don't we go around and introduce yourselves and what your cosplay interests are. And if you've brought anything with you, show and talk about what your piece is and what fun materials or processes you've used that are of particular interest to you with the piece that you brought. Emily, would you like to go first?
Yep. Hello, I am Emily Finke. I have been making and wearing costumes for 20 years. At last check, I was up to 200 costumes. I think I've made 3 more since then. But that could be duplicated. I primarily prefer working with fabric. I really like drafting my own patterns and draping my own patterns. But as you can see, I've done a little bit of leather work. I've done a little bit of Worbla. I do a little bit of everything. When I get bored with one thing, I jump to the next one.
Nice. Topher, how about you?
Hi, I'm Topher Hunter. I'm been doing cosplay work for about 7 years now, I guess. And while I've done some, fabric stuff, that's not really where my heart lies. The real thing that gets me excited is more the prop and accessory manufacture, whether it be, the electronics or the 3D printing and materials engineering of all those different kind of beasties.
Excellent. And Torrey?
Hello, Zuko here. Torrey. I'm Torrey Stenmark. I have also been costuming for about 20 years. I primarily work in fabric. This is all leather work here. Fabric dyes, pretty much all kinds of materials, and getting a little bit more into Worbla and prop building as well.
Excellent. And Ryan?
Hi, I'm Ryan Consell. I have also been cosplaying for 20 years and was just horrified to realize that's not like rounding down or rounding up. That's true. I started off in hard materials. I started with like metal armor and then worked my way backwards to soft stretchy spandex and EVA foam.
And that costume that you're wearing right now is?
This is almost entirely EVA foam and spandex.
Nice.
With some paint and Velcro.
That is very elaborate. So I have a lot of history. Let's see, I don't even know how long it's been now. Maybe about 15 years of doing 3D printing, vacuum forming, sewing, lots of different kind of hard material stuff like Ryan here. And it's been a really exciting adventure for me as well. And hopefully all of you coming here as well have your own histories and excitements. So we had a question from, let's see, who was it from? It's from, let's see, Jocelyn. What hypotheses have you tested in a recent cosplay? Excuse me, and have your peers replicated the results? Does anybody want to take a shot at that one?
Sure, because this is the science of cosplay and we're testing hypotheses. So building this, there were a lot of guesses. One was that I would actually be able to put beautiful, like picture perfect soles on the bottom of these shoes. And I spent a lot of time experimenting with the materials that you might make the sole of a shoe out of and adhering them to the EVA foam I could get with the adhesives I could get. And I have proven that those were not strong enough to hold soles onto the bottom of shoes.
Yeah, there's a lot of different stresses there that you have to account for. And adhesives are pretty crazy, right? Because there's, I think, 1 million different types. And
I had to promise not to talk too much about glue this year, so don't ask me that question.
Okay, well, moving right along. So we've all been in this for a few months now. We've been talking about PPE a lot. A lot of the questions that we got were actually around material safety. How you keep yourself safe and other people around you when you're wearing your costumes as well. What are some of the safety concerns that you've looked at recently or ran into, kind of like maybe trying to glue a sole on that doesn't quite stay on and you're trying to maybe walk downstairs, which would be a potential disaster. Topher, you got anything?
Yeah, I mean, one of the big things that came to my mind when I was thinking about that is we do a lot of work with both a laser cutter and with a Cricut knife cutter. And you know, they're very much complementary tools because each one is really good at a different thing, and a lot of that good at is related to the safety. Some materials are not safely laserable because either they have an exceptionally high melting point, so they deform and go to gook when you laser them. But you know, some materials, when you laser them, you're vaporizing the solid material, turning it right into a gas, and you can produce some gases that are either very dangerous for you, the individual operating the machine, or that can damage the machine. Some chlorine gases that can etch the optics in the laser. So read is really the key. Is read the guidelines on the material, go out there and look at forum. Yeah, don't ever laser something that you haven't tested and checked first and foremost. And don't downplay the incredible value of things like the Cricut. It's a much less expensive and really cool tool for doing some amazing stuff.
And for some practical examples, this is a leather plague doctor mask. It was entirely cut on the laser, and you can tell by just how neat and even all of the lines are, because I don't do that kind of precision. That's not my lifestyle. And this was perfect for the laser because it was originally undyed veg tanned leather. So that's leather that's not dyed with any, that was not prepared with any metallic processes. There's veg tanned and chrome tanned leather. You can use veg tanned leather in the laser. You should only ever cut chrome tanned, which is the more like, if you think of upholstery fabric, clothing leather, that's leather that's been chrome tanned. It's much softer, unless it's very, very expensive, in which case it might be veg tanned. You're probably not working with that for costumes. That kind of stuff you want to use a Cricut or a Silhouette, something that cuts with a knife, and you can still get those same beautiful lines without risking damaging your leather, your laser or your leather. So this is a chrome tanned leather here. And it happens to also be a metallic. I would never put this leather in the laser, in the Glowforge. I have, however, cut it with a Cricut machine. So the fanciest, shiniest thing is not always the best tool.
So what's the difference between chrome tan and veg tan, you said?
Veg tan leather, I do not know the...
Vegetable matter.
Yeah, it uses...
It's tanned using vegetable matter.
Yeah. Okay. And chrome tanned leather is tanned using metallic materials, and metallic materials will generally not react well in your laser. Your leather will turn to sludge. So,
sorry, go finish.
Oh, when I used the laser in this, it was just tan leather, like it was not red. I painted it afterwards.
Ah. And Torrey, you've got this equipment that we're talking about, and you have a passion for it and dyes.
I do. So this actually is all made of veg tan leather. It starts as a pale tan color, and it's been shaped and hardened as well as dyed and textured. And you really do want to use veg tan for most of your cosplay things. Like,
this is also veg tanned back here.
Particularly when you're shaping it, the chrome tanning process treats the leather in a way that is it's different from veg tan, and it's not as shapeable. So if you're making furniture, that's a different process. But when you're using cosplay stuff, you want veg tan, and you can get it in all kinds of thicknesses.
Unless you're making clothing. Like if you're doing a leather bodysuit, you want chrome tanned because you want that very soft, very thin leather because it'll go through your sewing machine. So,
Absolutely. Yeah.
Props and armor and anything stiff, you want vegetable tan. And it's sort of the default that you pick up at any sort of leather craft store.
Yeah.
Ooh. Also in the I make good choices for what to panel in. Also in the safety, all of the if you don't, I guess what I'm saying is don't laser in an enclosed space because everything is vaporizing and going in your lungs. And when you are doing any kind of work, probably wear a mask. You probably should wear a mask when you're sewing because a lot of the fibers, when you're cutting things, you get tiny fibers which go in your lungs, which probably aren't good for you.
Yep.
But that's only if you're doing a lot. But there's kind of
or if you're working with fake fur.
Ooh, yeah, yes.
Wear a mask if you're working with fake fur.
But there's kind of 3 categories of things that will go in your lungs. There's fibers or dust or dry material. There's liquids, and then there's gases. And you wear totally different protective equipment for all 3. Most of the masks we're wearing right now are sort of good for dry materials. They're pretty good dust filters, and they're kind of okay for liquids, despite the fact that liquids is what we actually want to be filtering. If you're going to be working with spray paint, you're going to want something that does both dry and liquid masks. You should get you can Google these and get a respirator that pulls out the right stuff. Just a dust mask isn't going to do it for you. You want a respirator that's actually going to pull out those particles. And if you're working with glue, you're going to want more than a filter. You're going to want something that can pull out the gases that you're working with because things are actually off-gassing, and you can't get a filter small enough with a fine enough grain, like a physical filter, to get gas particles out of the air because they're molecules. So when you talk about respirators for gases, they have things like activated charcoal that those hydrocarbons that are coming off the glue will react with and stick to. And if you're working with things like that, I don't know, if you're working with electrical discharge machinery, you want an actual oxygen tank because you've got ozone coming off that. But that's not really a cosplay problem, so I should skip that. If you're developing a lot of ozone, you're probably doing something very wrong.
At one point in time, I actually decided that I would start building a fume hood for my basement as well, so that I could just immediately exhaust any of the chemicals that I was working with. And so there's a, if you can immediately get them away from you, it's also a really great idea for safety.
Yes, good for you, less for the local birds.
Yes, yeah, exactly. And there is an environmental impact to all the materials that we choose to use, right? But locally still, we've got electronics that are getting their way into our wearables and our costumes and just our everyday lives that we have to worry about. And we've heard about iPhones and Samsung phones catching fire. Well, it's because there's a lot of electronics pumping a lot of current and generating a lot of heat. I think, Torrey, you might have a relevant story about electronics.
So I do a deep variety of costumes, including a bunch of superhero costumes, one of which is my Tony Stark, so I made my own arc reactor. I built it not in a cave, unless you want to call my workshop a cave, but I did build it myself from more or less a box of scraps. And I'm not an electronics kind of person at all. So my arc reactor it's electroluminescent sheeting. You might have seen EL wire, which is great, it was a wire, but it comes in sheets as well. So I have this flat sheet with alligator clips clipped to it, which runs through an inverter to a 9-volt battery. And you have to go through an inverter to change the type of current you're dealing with to get the EL to work. That's how it functions. So I put that together with a lot of electrical tape and alligator clips and some crossed fingers. And I had an exposed piece of something. And you know where you wear an arc reactor? Right over your heart. I am getting a red flag on this play. Yeah. And something shorted, something got touched. Yeah, I took a real unpleasant shock right over the heart for a very short amount of time. There was no damage, but it was a real weird feeling because your heart also runs on electricity. No more than I do when you do electronics. Topher, you probably are the person and the expert on this panel for that one.
So
Yeah,
I teach.
Ryan was just showing
the
EL
little inverter
sheet, and yeah, they, as Torrey was saying, they run off of these little battery packs, which is really cool because like you can get this glowing strand of wire, and you can, you know, this, I think this was for a costume that never happened, where I was going to have like red lines running through down my glove kind of thing. Anyway, but these little buggers pump out alternating current. AC current is what your wall puts out. AC current is really unpleasant to touch, even at fairly low voltages and currents. Not necessarily dangerous in the grand scheme of things. Thankfully, Torrey was uninjured. But yeah, they can be rather unpleasant, and that's why actually a lot of suppliers and a lot of cosplayers are switching over more to LED based. And I just happen to have a little LED gizmo here, but LED based systems, and you know, there's all sorts of great little things you can do with these programmable addressable LEDs. And these require a lot less power, a lot less current, and they're DC, direct current, which is a lot safer to handle. So now that's, you know, all the stuff that you've got in your costumes, it's not really likely to injure you because the voltage and the currents are so low.
So I spent a bunch of time so I was surprised. We put out a call for questions, and almost every one of us got a "Are electronics safe to wear?" question, which surprised me that people were so worried. And one of the things I do is teach circuitry to first-year engineers. So I spent a good chunk of time yesterday trying to figure out why an EL wire inverter won't kill you. Because I know it won't, but I had to do the math to figure out why it doesn't. Because they actually pump out about 100 volts. But that's peak voltage. The tiny little power supplies that they're running off of don't actually have enough power in them to kill a person or to meaningfully harm you unless you connect it directly to your muscles. So by the current passing through your skin between the two leads, it's going to activate your nerves and tingle in really exciting ways. But there isn't enough current passing through your whole body across your heart to actually cause your heart to see like to palpitate or freeze at all, or any of your muscles to do the locking up action that will happen if you grab, say, a live wire. It's a very high frequency, so they managed to get to a very high voltage for a very short period of time and then rocket it down in the other direction, which is how the EL wires basically work. Is we go hard to one side, hard to the other side, and the shift is what causes the things to start lighting up. But unless you connected that inverter directly across your heart, it doesn't have enough power in it to do you any harm. If you do find a way to connect it directly across your heart, it does have enough current, it can put out enough current to cause your heart harm. Like a pacemaker that's medical equipment can do that with a tiny amount of power, but an EL inverter can't do it. The power supplies we use for LEDs can't meaningfully harm you, again, unless you manage to jam the leads through your flesh directly around the muscles, which is inadvisable for entirely different reasons.
So you're saying my sewing machine is more dangerous than the electronics in clothing?
I would say the one thing you would watch out for, though, is a short that would short the battery pack. That could generate a whole lot of heat and potentially burn you or even ignite. So that would be the main thing I'd be worried about.
Yeah, so maybe don't use, what was it they used, Torrey? Like alligator clips and...
You should learn how to solder your electronics. But like,
yeah.
Adafruit has got great tutorials and stuff. There's a ton of stuff on the internet. So do that, ask these lovely
people. Shrink wrap
is
your best friend.
Yeah.
The other thing is if you're working with L panels, I made a project. So I've done a lot of mouse heads. This is a replica, or this is a modified mouse head to look like the Space Core from Portal. And I did a lot of those, and I made one that had a lot of L panel all throughout the inside so that it would glow a certain pattern. And what I did there is, even with it curved, you could paint all of the exposed edges with like an acrylic nail polish, and that'll at least seal the exposed anything that could be potentially electrically conductive. And so it's a really good idea to seal anything that you're doing electrically, if you haven't just wrapped it with electrical tape or shrink tube or whatever else. So we were talking earlier about dyes, and I think, Torrey, you said you were going to bring a whole bunch of knowledge on dyes. What have you been working on recently or in the past that's been really kind of creative and interesting along dyes?
Sure. So in my day job, I'm an organic chemist. I teach chemistry. And so dyes is a natural extension of that, because that's literally some of the first synthetic dyes were key organic chemistry inventions. So it's sort of a really fun synthesis for me of getting to talk about both of them. So the trim you see on my armor here, the orange and the yellow, is actually custom dyed silk. I dyed the leather. But my favorite piece here, we're gonna migrate the camera a tiny bit here. On the mannequin over here is my Padme Amidala gown, which costumers in the know call it her Rainbow Lake gown, because it goes rainbow sherbet colors: purple, orange, pink, lavender, yellow, this just beautiful confection. And that's probably the piece that I'm most proud of, is getting that ombre, that color change throughout it. And it's just a matter of sitting down with your dye, testing it very carefully, keeping very, very good notes, and then just keep doing it until you get the results you want. So I do all kinds of tests and things like that. People sometimes get scared about dye, but all you got to be is patient and careful, which is true of most costuming.
Can I ask some dumb dye questions?
Please.
How does it work, and why does it work on some materials and not others that feel the same when you pick them up?
So dye comes in three main categories. Fiber reactive dye, which works on plant-based materials. So cotton, linen, bamboo, things like that. If it's plant-based, it's made out of what's called cellulose, and the fiber reactive dye sticks to that. They form covalent molecular bonds to that type of fabric. The second category of dye are called acid dyes, which is the ones I grabbed here. The acid dyes bond to animal-based fibers. So silk, which is everything I'm using here, silk, leather, wool, feathers, anything like that. They use a different type of chemistry to connect to the fibers. They connect to different parts of the fibers, which are protein-based. So you get a completely different kind of connection that way. You can also sometimes get synthetic dyes, or excuse me, dyes that are made for synthetic fabrics, for polyesters. Polyester is built very, very differently from silk. So even though, we have, I just need to feel my fabrics a minute so I can remember which ones are which.
There you go.
So, sorry, go ahead.
Oh no, this is polyester, and this, which looks almost entirely the same as silk. Yeah. So
same thing here. These two, because I've got my fingers on them, I can tell which one is which. I can set them on fire to tell which one is which, but they will take the dye very differently because they're different materials. So your polyester dye will work on polyester, but your cotton or your silk dyes may or may not work on each other, and they almost certainly won't work on polyester, which is one of the fun things. This, that white strip at the top was dyed in the same dye bath as the yellow fabric underneath it. It's just that this is polyester, so it didn't take the dye at all, whereas the silk underneath it did. And that was the desired effect. It's supposed to look like that. So that's why I did that.
So I'm really curious, can you elaborate more on the setting it on fire to find out?
I like we have a running theme of fire throughout.
So Emily, did you want to talk about that, or?
I am not good at the chemistry. I can tell you what happens, but I can't explain the chemistry behind it.
So again, plants and animals are different. The materials we make from them are different. So the cellulose-based cotton, linen, things like that will burn very differently from the way the protein-based, the keratin fibers in animal-based products will. And the plastic that makes up a nylon or a polyester doesn't burn at all. It just melts. Because completely different kinds of bonds. I could go into chemical structures, but I didn't bring my whiteboard set up. So yeah, so when you set them on fire, cool things happen.
Yeah. The really short answer for the plastics is they have a very simple structure that will melt. So you always get, or almost all polymer fabrics, you get like a nice melted edge around the edge of whatever you've singed.
But do it outside because you don't want to be
yes.
breathing in most polyesters once you burn them.
Yeah, I think this also used to be called the cigarette burn test.
Yeah.
Except nobody has cigarettes anymore, so now we like have to find other things to get hot. But yeah, you don't actually have to usually set these things on fire. You just have to get a thing hot enough that it will like make a good burned hole in your material, and the edge will tell you whether it's a natural or synthetic. If it's ashy, it's natural. If it's black and melted, then it's synthetic.
And this is where science really can help you save money on your supplies, because you can go to the unlabeled pre-cuts at a remnant bin or a store, buy it, burn it, see if it creates a bead of plastic, or if it burns like cotton, and then you know how to take care of it. So you don't have to go for the more expensive fabric. You can trial some cheaper fabrics to find something that'll work well.
It is
I
recommended
swear
that
you were
buy
about to recommend walking to a remnants bin with a lighter.
No, and that is why I'm not allowed
don't like
into
that
it
one.
anymore.
So
Actually,
speaking-
I recently bought a bunch of fabric off Amazon because I was trying to find some stuff to make masks with, and several things that I was sold as cotton immediately melted into like nice little plastic beads of fabric.
Oh, wow. That's a good quality control question too. When you start to get into science, you need to make sure you know what you actually have, right?
Yeah.
So we have all these big structures for figuring out the validity of materials, and that's a whole other panel maybe we can do in the future. But when we're talking about fabrics getting hot here, I have a question that was sent in from Kristen asking, why did my fabric change color when I iron it?
So
Torrey, you seem.
I mean, I'm happy to let Emily talk fabrics as well.
Oh, sorry.
well, there's two different mechanisms, and I can talk about the physical mechanism, and then you can talk about the chemical mechanism.
Go for
Does
it.
that work? So a lot of fabrics that are not particularly iron safe, the act of pressing them will actually flatten the fibers into a different color, particularly with velvets. Some silks do this. And as soon as you iron them, you're actually like changing the physical structure of the fibers. You're putting them too close together. You are flattening them down in a different way. So you have to make sure you're always pressing very carefully for your fabric, very gently, or just don't press certain things. Do you want to talk about the chemistry?
Yeah, sure. If you're real unlucky, you can melt your fabric. I definitely have made a costume out of patio furniture fabric. And definitely there's a couple parts on it that are kind of crunchy because as the fabric starts to melt or break down, you can lose the dyes. You know, the chromophores, the pigments that give it color, can break down with heat. And then the fabric itself can break down, and then you just have a big old iron burn mark in the middle of your pants and have to remake that part of your costume.
Now, there are ways to avoid that. Again, using science. You can buy Teflon mats. So this is a piece of vinyl. Normally, you don't actually iron vinyl because it melts. It melts at a very, very low temperature. So you don't, even like the lowest iron setting will not do much. So instead, you take your vinyl, and I was ironing some iron-on vinyl onto this marine vinyl, which is a fabric. And I put a Teflon mat, the same kind you would use for baking, basically. You buy them for sewing. They're more transparent so that you can see what you're pressing underneath it. And that Teflon actually creates enough of the barrier that you're not damaging the fabric when you use it. So.
And nothing sticks to Teflon is
Yeah.
one of the other things that even if
Yeah.
it does melt a little bit and start to get tacky, because
Yeah.
things like vinyl, even below its, or even above its melting temperature, it starts to get a little bit adhesive, which is why it immediately sticks to your iron.
And do
but it
not
won't stick
touch,
to Teflon.
do not touch your vinyl right after you've ironed it. Let it sit on your ironing board. Let it cool down, then pick it up, because it will hold enough heat that it'll try to adhere to your fingers. I didn't
it'll
do
pick up
that
your
last night
fingerprints
or anything. Yeah, it will pick up. I do not have a fingerprinted one right now. I threw that away, but yeah.
I got fingerprints in my EVA foam because I was not careful enough.
So talking about material sticking, we have another question that's a little bit off, but I think it's a sufficient segue here. How do you get paint to adequately stick? And I'm paraphrasing because I can't find it right now. But how do you get paint? How do you
get paint to stick to stuff?
Yeah, basically. But mostly, specifically, they were asking about plastic. So that was from Tim. So Ryan, it sounds like you're.
So I mean, there's a lot of answers to that. One of the things that you run into most often with paint not sticking is that the solvent that the paint uses doesn't at all react with the surface you're painting to, which is usually good. And if you're painting to a really smooth surface, there's very little surface area for the paint to adhere to. So you're basically sticking something that's moderately sticky to a sheer sheet. So if your plastics are really shiny and really polished, then there's not a lot of surface area for the paint to stick to. There's a couple ways to avoid that. If you rough it up with sandpaper, then that rough surface is no longer just flat. It's got a bunch of ridges, which multiplies the surface area that you have for the paint to stick to, which means it'll stick a lot better to that surface. Anything that carries an etchant, so a lot of primers, if it's the right kind of primer, will etch the plastic. And the purpose of etching is exactly that. It's to take that smooth surface and make lots of tiny, tiny little pits and bumps, which all it's doing, the only change that's happening to what the paint is sticking to is making way more surface area for it to stick to and in different directions. So even if you pull it a bit at the edge, it's not all coming off in a beautiful clean sheet. It's got to go over bumps and nooks and crannies, kind of like trying to make it stick like Velcro to each other. I feel like Topher is moving around like he's got things to say.
Well, I was just trying to figure out if I had an example on him, because aluminum is a notoriously bad material to paint. So this guy, he's entirely aluminum. And so yeah, there was an etching primer that went down on everything. And then there's some cool tricks that I did too, which if we want to, we can get into it, and is cool tricks for getting the enamel to lay on really hard and smooth. But I don't know if
I want to know.
So aluminum is a fun material in that, so especially of course in props, lightsabers and all that kind. It doesn't stick well to a lot of paints. So you have to first use an etching primer, which is what Ryan was talking about, that chemically etches the surface and creates some reactivity out of the aluminum because of it. Oh God, just realizing I could go way off topic there, because it's basically the antioxidation properties of the aluminum that's causing all that. The fact that it doesn't rust is part of what is making it really hard to bind a paint on. So the etching primer takes off that protective layer a little bit. Then you lay down your enamel paint on top of the primer. And then if you have small pieces like these, you stick them in the oven at about 200 degrees for about an hour. And what happens is that the enamel, which, no matter how good you are with a spray gun, the enamel is always going to lay down a little bit rough and wavy on the surface. But if you heat it at the right time, enamel will still flow. And so you can get this beautifully glassy surface. And of course, you can't see it anymore on him because I love to weather my droids extensively. And so it doesn't look all shiny, but
So you spend hours getting it perfectly flat, and then you kicked it down a flight of stairs?
Yeah, pretty much. Yeah. So it's a really cool trick for small parts that you can put in your oven, and of course, do it at a time when you can open the windows and turn on the fan, because this is not a good thing to put a drip pan so you don't get gook in your oven permanently. But that oven baking technique can make some beautifully smooth, and it also happens to actually harden the enamel really well. So you get a very durable surface. So when you're making a lightsaber hilt or something, it can take a beating.
Yeah, the one thing from my history that I've found is that when you're talking about paints and finishes of any sort, it's all in the preparation, really doing your research to make sure you are doing all of the lead up things, which take 99% of the time. And then the application is about 1%. So there's a lot more to it than the surface, let's say.
But Torrey and Emily, you have some really neat painted things that aren't plastics there, and those are different tricks, right?
Well, we both have leather paint, which is, I have a combination of leather paint and leather dye, which is two distinct things. So this, and it's intentionally not shiny. Oh, I forgot I had something hanging off of it. This actually uses a leather dye, which absorbs into the leather to create the blue that, of course, you can't see because everything's casting yellow in my room. And then this over here is the gold is an Angelus leather paint, which is great because you can actually move it. You can bend it. It won't crack. It's extremely durable. It won't actually rub off. It won't melt off. I love Angelus. And all of this is painted with Angelus. So this is all leather, and you can see, well, you can't see it because I didn't use much dye, but this is actually the color of veg tanned leather before it's painted. So, and then I actually have a different kind of plastic. This is a painted Warbler, but I used metallic lacquer from nail polish. I used nail polish to paint this because, again, yeah, dollar bin CVS nail polish. It costs like $4 to paint the red and $2 to paint the gold. And what's great about that is it also flexes. So this it's of course a completely impractical armor that would not sit off anything, but it will flex around my body. So, and the nail polish will not chip off with any of that. So it's the same as hobby paint, but it's cheaper than hobby paint. So
how flexible can you get there? Is there a limit, or is it you could fold it?
So I made this to wear in 7-degree Atlanta heat, humidity. This basically melted on my body when I was wearing it, and I have not touched up the paint at all.
Wow.
And it looks amazing in person.
Yeah, and that's because nail polish is actually formulated to flex with your nail. Like people would not put nail polish on if it chipped right off as soon as your nail bent. So I figured it could use it for plastic. And of course I tested before I did this. I probably didn't test much because it was the lead up to con, but I tested to make sure the lacquer would not melt the Warbler, because some things will melt Warbler. So
I've walked around Atlanta in that heat with painted Warbler as well, but I used acrylic, and it was not a great result. So
yeah,
next time I'll
that
use
was
nail
what
polish.
I was trying to avoid, or hobby paint. It's just nail polish was available to me at the time, which was probably like 11 p.m. on a Friday, 2 weeks on. So
Torrey, do you have anything to add to the paint discussion?
I really love Angelus leather paint. So this here, the fine detail texture is actually stamped into it and dyed over it. So let me lean in for the camera here. There's teensy tiny flames stamped into every square inch of all this leather armor, plus the greaves you can't see on my shins. And you stamp that in, and then the dye goes over it. And because it's a dye, it's a physical texture carved into the leather, and the dye just soaks right into that. You can see a little bit the flames carved into my bracers here, hand carved, and then I painted the dye into the carving, so you get a little tiny bit of a yellow effect. It's pretty subtle, but it is sort of a little bit of color going on there. And then the metallic gold, so the edges here are silk. but the metallic is the same Angelus paint Emily uses.
Yeah.
I've also changed entire shoes. So what I did for the first set of shoes I had with Padme here was to get a pair of thrift store shoes, strip the finish off with rubbing alcohol,
Do
and
that
then
outside.
yeah, I should have done.
Yeah.
And then repaint them with Angelus, and it flexes, and it's great.
Yeah.
I wore those shoes to go climb around a rocky beach and tide flats, so they got destroyed, and I had to replace them. But the paint isn't what failed me; it's the everything else.
And Angelus works excellent on fake leather too. So if you need to, if you're vegan and you don't want to use leather, Angelus works beautifully on vinyl, and you don't have to prime it or anything. It actually just takes really well. So.
Brian, what'd you use for your EVA?
Oh my goodness. So base coated in, give me a second. What's it called? Flex Bond. I have heard good things and wanted to try it out. It is slightly better than white glue. It smells like white glue. It flows a bit better than white glue. There's a reasonably good chance it just is white glue of a certain brand. And that was to basically to seal and prime the foam, because the foam is foamy, so it's very absorbent. So you got to do something to keep the paint you actually want on it from soaking in. So that's sealed and primed, and it's intentionally very flexible, so it moves with it. Then just straight up spray paint out of a rattle can for the colors. Some airbrushing for the bits where I couldn't get a rattle can of the right color. And it's fine. I wouldn't trust it for like high endurance kind of stuff. This is a delicate paint job costume. But there's your summary.
Awesome.
I had an interesting kind of accidental experience with I was working with some EVA, same stuff that Ryan stressed in, and I did the sealing. I did both a heat sealing and a glue sealing of the foam. So just ran over it with a heat gun, and then painted it with a white glue-like solution to seal it up. But then I actually used leather dye. I don't know why I thought this was a good idea, but it turned out to make the most beautiful, like, roughened finish. I mean, you hold up the piece, and it's downstairs, or I'd go grab it, but you hold up the piece and you can't tell it's not leather. But it has all the advantage of being able of the weight and being able to shape it like EVA foam. So
people use the heat sealing of foam to give it a leather texture. They'll actually put a piece of crinkled tin foil on top of it, run an iron, or if you're using your iron, put something in between your iron and the tin foil, you'll ruin your iron, or a heat gun, and they'll actually press that tin foil pattern into the foam, and it makes this beautiful leather look when combined with dyeing.
Yeah, that's really unexpected. Wow.
Yeah.
So let's jump into kind of like the bigger scale of doing cosplay here. I think, Ryan, you might have a pretty good opportunity to speak to this right now. There was a question from Kathleen on how do you plan an outfit so that all the pieces fit together, particularly outfits with hard materials or armor.
I feel like this is one of those questions that, like, you can go either way. You can be, let's go the arts way, and you go, well, you sort of guess and check, and you make some prototypes, and you see how they work and how they fit. Or hard the other way, and you 3D model the whole thing, and then get like some rapid prototyping to build it for you, or to shove it into Pepakura and unfold that pattern for you so that you can then make a pattern. And usually the right answer is somewhere in between. If you guys don't know what I'm talking about, there's cool software originally made for making like paper models of things. You feed it a 3D model, which is always just a bunch of triangles. And there's a program called Pepakura that will look at those triangles and unfold it for you so you can print it on a flat piece of paper. And then you can fold, and it'll put little tabs in it so you can glue it back together as well. you can use that in combination with something like Blender, which is a 3D modeling program that is free, to make a 3D model that you can then unfold into a piece of paper if you can't figure out the geometry yourself, and then rebuild that into a pattern you can build, which is how I built the helmet. So I got a 3D model of this, mashed it around until it had the right number of polygons, and then unfolded it, printed it, modified the pattern, put it back together, and that was the base pattern I used for that. For something like the shoulders, it was a lot of, I got my rough measurements and then I artfully massaged it. And for a part of the backpack, which I don't know if you can see, it's the first cosplay piece I ever used polar coordinates and calculus to figure out how it worked. So at the top in the middle, there's sort of this little floating weird shape that just sticks out. I don't know if it's visible.
Yeah.
That I spent more time working that out than is at all reasonable. I tried to just like be like, I think this is what it will work. But it has a series of saddle curves in different directions and a curved sloping seam.
For a saddle curve, think of a Pringles chip, right? Curved in two different directions.
Yes, or a saddle, like a horse saddle. Hence the name. But yeah, Pringles chip. So it's got like a Pringles chip curve around one direction and a sloping convex curve around the other direction. And I could figure out the geometry mathematically better than I could figure it out artfully. But normally the answer is do a bunch of, because usually we're putting them on human bodies, which are disgusting meat bags with gross geometries and moving proportions. Giving yourself space to flex and stretch is how you actually, and things that just overlap so they don't have to perfectly butt, is the better way to do it. It's cheating from my point of view, because my background is engineering, and every time I do something without like perfectly dimensioned drafting, I feel like I'm cheating. But usually cheating's the right choice, and building it a piece at a time and building off of your central most important one and adding on as you go. Other opinions?
Oh, I believe Torrey and I both come from the opposite background. You're a draper as well, right? You drape patterns?
Generally,
so,
I modify as well, but yeah.
Yeah. So Torrey and I both use a clothing construction method called draping, where you take a dress form and you make pieces that you think are close to what it's going to be. You actually pin the fabric in a muslin, which is the test run fabric, the cheap test run fabric, to your dress form, see what shape it makes, take it off, put it on your body, pinch things in where it needs to be pinched in, let it out where it needs to be let out. So this pattern, I used, I think, 3 different patterns to pull base shapes from. And then I took that from there and then draped in a stretchy fabric in the middle. So absolutely no math. Engineers will walk into my sewing room, see me in a puddle of fabric, go, and just walk right out again. Mostly the engineer sitting with the droids. The only calculations I did with this one was I wanted to get these curves equal. So I did basic math to see what curves I needed. And I did a little bit to figure out what gathering I needed in the sleeves, because gathering is very hard. Sleeves are hard for me. I have a very hard time draping them. So I almost always go to a pattern block, which is a different method of creating patterns, where I take a sleeve that I know fits me and then go, well, I need more fabric at the top. What do I multiply that top arc by to give myself more fabric? And it's always some number that I don't really, I'm not a math person. I am a hit rocks with hammers person. So yeah, so I do a little bit of math, but I don't really understand it, and I'm kind of angry at it. But everything else I do draping. And then this is actually, I took apart a cheap corset, cut it apart, added seam allowances, and made a leather corset. using the pattern pieces from that corset. So again, no math, no engineering.
No, that's engineering. That's it. I think there's
It's practical
oh, yeah.
engineering.
Yeah, it's there's a wonderful illusion that we engineers like to manufacture and pretend is true. That we are some kinds of geniuses that manifest things from the ether through our genius. But all we ever do is take apart a bunch of things other people made and go, well, I'm going to steal all these ideas. Maybe add this little bit of my own.
Yeah, I consider everything I make a experiment without a control group.
Yeah,
Like, does that work?
The thing that I've always heard, Ryan, is that scientists discover things, and then engineers take those discoveries and then apply them, and it's almost always an iterative process there. So I'm there with you. So we also have an interesting topic about turning 2D things into 3D things, which we've already kind of gotten to with the draping. When we talk about like hard materials, though, something that you might not get is that when you turn a flat piece of sheet metal into a sphere, which Topher, you've got your spheres of aluminum over there as well. This is a perforated piece of sheet metal that's used for a mouth, the front mouth of a mouse head, and it allows you to breathe really nicely. But when you take the flat sheet and turn it into a sphere, you're actually flowing the material, and it's really difficult if you don't have that internal concept in your mind. And you can see here the perforations actually allow, and I'm hoping you can see that well, the perforations allow you to see where the flow of the metal didn't go quite nicely, and it stretched too much locally here and didn't stretch as much over here, and ended up forming a rip. So so there's a lot of really cool aspects to that. What do you got over there, Topher?
I was just going to say, there's, that's why sometimes creating rounded structures with 3D printing is by far the more stress-free, at least as far as I'm concerned. Yeah, but I think
absolutely.
Ryan's got something cool there too. And is that?
Yeah, so this is an aluminum, I think it's 3/16 in American, about 3-4 millimeter aluminum. And I started off in armor smithing and then moved to quieter hobbies. But this is whatever you do in armor smithing, you can also do in Warbler. And it's basically the same process in EVA foam as well, but to a smaller extent. When you are trying to make a dish or any kind of like long dome, you have sort of two choices. You can dish it or you can sink it is the formal words for it. But dishing is stretching it out from the middle, basically blowing it up like a balloon and stretching it out. Raising is working it from the middle outwards, squishing it usually around a form. And it's much easier to do with a piece of plasticine or clay, but you can just sort of squish it down as you go. And that's the process that you would use if you wanted to keep your metal from becoming, or Warbler, from thinning out too much. Do I have anything here that I did that with? Yeah, so again, don't wear costumes that don't fit in the room you're in. It's a terrible choice. This is the only time for Dragon Con I'm going to get to wear this, so I chose it anyway. But here is, probably too far away, sort of a really deeply domed bear face that I made a long time ago. And if I bring it closer, got to walk back to my microphone. You can see how deep I had to go. And if I just did that sinking it, it would have gotten really thin and torn open. So I had to raise it, which meant hammering it down and squishing the metal around a post. And that lets you keep your thickness as you go. And it never thins out if you do it right. And you can keep the thickness about the same. Yeah, Emily?
Yeah. Oh, I did the exact same process with this, but what I used was an actual padded bra over a balloon, I believe, and did the same pushing it down around the cup rather than trying to push it out so that it would make I see a lot of people make boob armor that has clearly structural insufficiencies at the point because they tried to push it out.
Yeah,
Ryan.
Ryan.
Out in the middle.
So
and it also that. Oops, sorry, Zoom problems.
So to go into just a little visual of that, it's the difference between taking the material and stretching it out like this so it gets thin, or starting it this way and then crunching it down inside of itself, right? So you're kind of building thickness as opposed to stretching out for getting it thinner, right?
Yes. An easier visual is that the sinking or dishing is blowing up a balloon. That one's easy to visualize. If you take a dough or like icing and you put it over a bowl, it will naturally sort of collapse and you'll get those ripples. Or like any kind of sheet of paper, if you put a sheet of paper over something domed and just sort of crumple it around, you get like the ridges. Raising is a way to sort of mash those ridges down nicely. So you, instead of stretching out that middle piece of the piece of paper, which you can't do, it'd tear, you are mushing the outside together.
Yeah. Yeah, good.
Slowly.
I like that. So,
briefly, that's fabric darts. When you're trying to shape fabric around a curved body, when you're trying to fit it to hips or breasts, you actually cut out a piece of the fabric and bring it together. Sometimes you cut it out, sometimes you just pinch it, but same thing.
Actually, I guess you can see here.
Brilliant example. Thank you.
Yeah, so I've also got a piece from an Alex DeLarge cosplay that I did, and you can see where the seam, if I can figure out how to do this in my camera, there's a seam going straight down the front here where the flat fabric had to go around these interesting compound curves, and it was a really fun project, actually. It's really an engaging engineering issue or problem to solve, to figure out how to get something flat to be curved.
I often refer to this whole pattern drafting process as mathing myself a dress. A lot of it's draping, a lot of it's that sort of more intuitive math of try it and see. And sometimes it's, okay, the fabric is so many inches and my waist measurement is so many inches. How deep do my pleats have to be to take up that much fabric? And it's really kind of a fun synthesis of as Ryan was saying, in the middle between the art and the science is the costume.
Yeah.
Corsetry. I've just started to learn corsetry, and there's a lot of that. And it's really interesting because you're like, okay, I need to take up this much slack over this much distance, but divide it across this many seams, but I don't want this one to pull in as much as that one. And you end up with some beautiful, beautiful sine waves to make that happen.
Yeah.
Which I don't know is as satisfying to other people, but I think it's very pretty.
It's satisfying to me.
All right, good.
It's why I like
just a math
corsetry.
nerd satisfaction.
I think calculus is beautiful, personally.
It's very pretty.
We did have a lot of questions before we, as we start to wrap up here, we had a lot of questions on cleaning fabrics and cleaning costumes. So we've got, let's see, we'll try to rapid fire through these. We had one from Liz. How do I clean a costume with feathers? And Liz had tried vodka and vinegar and it did not do the trick.
So I actually did some research on this one because I was determined to get Liz an answer for this. And you test your materials first. Do not try this with your costume, particularly with feather costumes, because people use various different ways to attach the feather. You just don't want to put stress on that unless you know what you're doing. So test with some test feathers first, particularly if you've dyed them or painted them in any way, but baby shampoo, which is also how you clean wigs. So it's delicate. It doesn't leave much residue. It's also how you clean birds in rehab. So it kind of makes sense. But for millinery feathers, so making hats with feathers, everyone suggests using baby shampoo and basically gently spot treating it rather than submerging an entire item in water. You take a section, you apply your shampoo, you rinse it out very gently, and then you move to the next one. You can also apparently use lingerie wash, which is made to not you don't need to rinse it as much. Unlike a soap, it's made for the very delicate fabrics and lingerie. But because there are so many different kinds of lingerie washes, everyone says that you should test it with your item first to make sure it doesn't have something that's going to mess up your feathers, because feathers have a very, very intense interlocking structure. And you don't want to get a lingerie wash that's using something that's going to break those and make your feathers look ratty. So yeah, baby shampoo. Who knew? I did not. I do
Does
now.
that appear to work on hard surfaces as well, like painted surfaces, or is it really just for fabrics?
That's for fabrics and feathers. You probably, baby shampoo isn't going to be the thing you're going to for most plastics, I would guess. I would guess you would probably start with water. Check to make sure you're not going to make it run or anything. But yeah.
Does anybody else have any experience
with
Ryan?
feathers?
No, let's say hard plastics and
hard plastics. Very often you can just go with like all-purpose cleaner. Always test to make sure it's not going to mess up your paint job. But most all-purpose like bathroom cleaners, not the intense stuff, just the like use this on every surface whenever. That'll be fine on plastic. Evaporates pretty clear. You know, wipe it down, spray, wipe. Usually good enough.
All right. So I guess that's the answer to how we get rid of confunk as well. So we've got at least 2 different applications here. Torrey, you got something else?
Confunk is half vodka, half water in a spray bottle. Flip your costume inside out, spray it down, particularly the pits, anywhere you've been sweating in it, and just leave it to dry overnight. It's an old Broadway theater trick. I learned it in high school, and it works wonders. If it's real stanky, I have a polyurethane purchased Captain Marvel costume that I wore, you know, for many hours on the back steps of the Hilton doing a photo shoot last year, and it was rank, we're gonna go with. I just hung it in, not in the shower, but hang it in the bathroom where it gets steam. Treat it with a lot of vodka, but the steam can sort of also help dry it out and just sort of accept that it's gonna have some funk until it's gotten a lot of fresh air, but it's fine now.
Huh. Well, that's good to know. I'll have to pass that on to my Rocky Horror cast as well. So the other question we got with cleaning was about embedded electronics. How can you clean things with embedded electronics? Anybody have any ideas?
So if you've done it right, almost any cleaner will work. Because if you do your embedded electronics right, they are basically, you could almost submerge them and they'd be fine. As long as you like pull the power supply first. Sorry, pull the power supply. Almost all your electronics, your Adafruits and your Arduino boards all of the electronics are very well sealed. They're pretty resistant to water. So as long as you're not like soaking them or putting them in anything like nasty that's gonna dissolve them, they're gonna be fine as long as you let them dry out before you apply power again. Just like how you drop your phone in your toilet, as long as you let it dry long enough, it'll be fine.
That's good to know. So the last thing that we can do to wrap this up is literally talk about wrapping it up. Someone had a question. Let's see who was. Sally had a question. How do you get hard costumes into a suitcase? And we could expand that for a couple minutes into just in general. How do you get your costume to the con? I know I shipped my costumes through the USPS once, and that was a bad idea because it's a holiday weekend and I almost lost one of my mouse heads because I wouldn't have been there to even pick it up after the post office opened back up. And I found that the airline will take boxes and you can just pay for it as if it's a bag, as long as it's within the size constraints. But I took this this box from I don't know if you can even see it, but it's like a yard, like one of those ladder ball games, and it just fit a prop perfectly. And so I used that to transport my stuff.
Yeah, so the short answer is basically the same one I had, is spend lots of money. But if that is not an option,
My option is just wrapping the hard things and soft things. That's what I do. I take all soft clothing for conventions, so mostly dresses and leggings, and I wrap all of my armor pieces, anything that I think can be deformed, particularly with things like Warbler, which if they get too warm, they will deform. I'll support those really carefully so that they won't get pressed in a suitcase. I travel with feather bedecked top hats fairly regularly, and I've gotten very good at just wrapping the feather along the hat, then wrapping clothing in the same direction so I don't break any of the feathers. Just don't put your hard things next to your hard things.
There's good reason for that. For other reasons, very often your hard things have coats of paint on them.
Yeah.
And often paint won't stick to anything. It's very good at that, except paint of the same kind, especially if it starts to get warm. So if you have, like, if I put these things right next to each other in a car, I would probably find at the other side that they were now one piece, or one piece that was twice as painted and one piece that was not at all painted. And latex, I think anybody that's ever worked with latex knows that that's triply true. Latex touches another piece of latex, it is one piece of latex forever. So always test your materials and put materials that it doesn't stick to between it. Yeah. Paper is great for that. Like a bit of tissue paper, very little will stick to tissue paper, but not nothing.
And an amendment to what I said earlier, do not put your like polyester fabric up against your plastic. That can end up poorly with, particularly with paint jobs. So put your Lycra is fine, but Lycra, cotton, anything like that is fine. Don't put your completely plastic Captain Marvel with your plastic armor.
And along those lines, you can actually look up, if you Google search material compatibilities, there's lots of sources where you can get ratings of how compatible materials are and how reactive they are to each other. So if you know what you've got for two different things, I've got an acrylic paint and I've got a polyester fabric, you can look that up and it'll say no go, super reactive, and then keep those things away from each other. Topher, what about you? How are you getting your droids and large apparatus to the con?
These guys only go in the car with me. I'm never gonna air transport these or ship them in any way because I just don't. I know people who do transport their droids or their big props through USPS and UPS is actually really good at heavy logistics. They'll move they'll move a friggin' house if you pay them enough. But probably the more practical concern is prop weapons. If you're going to fly with them, be sure to do your research ahead of time. Of course, sometimes the best travel case is going to be a gun case. Like we have two of these beautiful, they took me forever to work on these beautiful phaser rifles. But the only safe way I could find to transport them that I was comfortable with was a fully padded gun case. But then you get to the airport and try to check that in and it's like 7 kinds of hell with all the extra paperwork and everything and locking it and all this stuff. So just do your research ahead of time. I would continue to travel with those phaser rifles in the gun case on the plane, but it is not like just checking in regular life.
But not carry-on. The gun case did not go carry-on. Yeah, I just want to make sure that's clear. That thing does not travel carry-on.
That's it. Lightsabers, because I'm in the Star Wars costuming community. Funny that. Lightsabers are frequently transported. There you go, Ryan.
One of Topher's.
Go to an art supply store and look for a poster travel tube. There are some really nice telescoping tubes. It's 2 pieces, you twist it and it'll extend and lock to whatever length you want. Great for transporting lightsabers.
Yeah.
Well, I love that. Is that the one that we made, Ryan?
Yeah, this is your electronics, my handle.
God, I'm so happy with how that blade lights up.
Well,
it looks great on video.
Excellent.
This box here, used to contain a gun at one point, a prop gun, and so I put this nice label on there to to make sure that they knew this is a non-functioning theatrical prop. Another good idea to clearly label all of this.
Absolutely.
So,
but when I had that exact same label on the gun case for the phaser rifles, and they still insisted on treating it as if it was a real gun. So
I believe it. Yep. I mean, we've all had those experiences going to con and having our stuff questioned. So we've dealt with it at one point or another, but you know what? This year it's virtual, so we don't have to worry about any of that. My name's Matt. I have an Instagram at Angiris Arts. It's ANGIRISARTS. I've got a lot of history up there of neat things like mouse heads and other costume projects. So that's where you can find me.
Hi, I'm Ryan. Again, I am student of Whim on Instagram and Twitter and the TikToks now. So find me there to see costumes and making things and science.
Hi, I'm Emily Finke. Again, I'm Celix on the internet, SEELIX. You can find me on Twitter, Instagram, and occasionally even on Facebook.
I'm Torrey Stenmark. My cosplay Instagram and Facebook pages are Tereshkova Costuming. And if you want to find me on Twitter for content beyond just cosplay, that's Tereshkova 2001.
And I'm Topher Hunter. If you're just looking for me, it's Topher Hunter. But my primary social media presence is as Northside Droids or Northside Droid Factory, where you can see these guys and all their antics.
So thank you everyone for being part of this panel. I think it was a great conversation, and thanks everybody for tuning in. And we hope to see you at Live Dragon Con in 2021. But thank you for joining us for Dragon Con Goes Virtual.